Alright, this video is about 8-3 trigonometry. Now, trigonometry only works with right triangles. Make sure you remember that. Alright, we dealt with special right triangles in the last video. Alright, so trigonometry only works with right triangles. Alright, it only works with right triangles. Don't try to use this with any other type of triangle other than a right triangle. Alright, you have three trigonometric functions. Alright, you have sine, which is the opposite side over the hypotenuse. You have cosine, which is the adjacent side over the hypotenuse. And you have tangent, which is the opposite side over the adjacent side. What exactly do I mean by that? Alright, so say we wanted to find the sine of angle A here. Sine of angle A. Well, we know that sine is opposite over hypotenuse. Alright, so little a is opposite big A. Alright, see how it's on the opposite side of the triangle? Alright, so since little a is on the opposite side of the triangle, that means that it is the opposite side. And of course C is always opposite your right angle, so C is the hypotenuse. Okay, so in relation to angle A, this is the opposite side, this is the hypotenuse, and this is the adjacent side. If you think adjacent, if two things are adjacent, they're next to each other. Alright? This side B here is next to the angle. So that's the adjacent side. Of course, the other leg is the opposite side, and then the hypotenuse is, of course, the hypotenuse. Alright? So, sine is opposite over hypotenuse. So if we wanted to find the sine of angle A, it'd be opposite, which is A, over hypotenuse, which is C. So the sine of A is A over C. Now the cosine is adjacent over hypotenuse, alright? So cosine of angle A, alright, you go to A, you find the adjacent side. Well, it's the side next to it, so it's B over the hypotenuse, which is C. So in this example, it's cosine of A is B over C. Alright? Then of course the tangent of A, tangent is opposite over adjacent. So for the tangent of A, you're going to go to A, find the opposite side, which is A, over the adjacent side, which is B. Alright? And this is how you would find out, and this is how you would set up your trigonometric functions. If you want a way to remember an order of this, you can remember Sohcahtoa. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So you can remember the acronym Sohcahtoa. Or, the way I learned it, as long as you remember these go in order, sine, cosine, and tangent, and on every calculator I've seen, that's the order they go, so that kind of helps you out. If you remember, Oscar had a heap of apples. Okay? That's the way I learned it. It's a little easier to remember how to spell, because honestly, I couldn't remember how to spell this in high school. Alright, so sine, cosine, tangent. Oscar had a heap of apples, and that's the way I remembered it. Alright, but you can remember it any way you want to. So, let's actually look at an example and fill out some sine and cosine values here. So the sine of t, we know from the previous board that sine is opposite over hypotenuse. So we're looking for angle t here. The side opposite t is this side right here. So for t, this is the opposite side. And of course, this is always the hypotenuse. Okay? So for sine, it's opposite over hypotenuse. So it's 8 over 17. No need to reduce it, just leave it as a fraction. Now let's look at cosine. We know cosine was adjacent over hypotenuse. Well, for the adjacent side, we go to t and we find the side next to it. That would be this side. So this is the adjacent side. So cosine is adjacent over hypotenuse, or 15 over 17. Alright? And now tangent is opposite over adjacent. We already know that the 8 is the opposite side, and the 15 is the adjacent side. All right. Now, all of that was in relation to t, which is what our original example was. But now let's look at g. Now, when you're dealing with angle g, the opposite side is no longer this side, because this is now the side next to angle g. So instead of this being the opposite side for angle g, it is now the adjacent side for angle g. And since the 15 is on the opposite side of the triangle from g, this is now the opposite. All right? So as you can see, the opposite and adjacent sides are relative to what angle you're using. If you're using g, this is the adjacent, this is the opposite. If you're using t, this was the adjacent, and this was the opposite. All right? So, just remember, the opposite side is the side that is on the other side of the triangle from the angle. And the adjacent side is the side that is next to or touching the angle. All right? You'll have to remember that. So, the sine of g, we know sine is opposite over hypotenuse. So, opposite is 15. Hypotenuse is 17. Cosine, we know, is adjacent over hypotenuse. So adjacent is 8 over hypotenuse, which is 17. And then tangent is opposite over adjacent, so 15 over 8. All right? So this is how you figure out your trig values. You get your triangle, you figure out which angle you're taking the sine, cosine, or tangent of, and then you figure out which side is opposite, which side is adjacent. Remember, for g, this is your adjacent side because this is the side next to the angle. It's also touching the vertex. And then this is the opposite side because it's physically on the opposite side of the triangle from g. And of course, the hypotenuse is always opposite the right angle. The hypotenuse will never change. This will always be the hypotenuse. But now for t, since the 15 side is touching the angle, touching the vertex, this is the adjacent side for t, and this is the opposite side for t. All right, so don't get confused about that. Opposite and adjacent change depending on which angle you're using. All right? Now, what happens, so if you have an angle and you're asked to find sides, this is how you do that. But what happens if now we want to find the measure of angle x? All right, what happens if we want to find the measure of angle x? All right, so here's what we would do. All right, we want to find this angle. First thing you want to do is identify what sides you have. All right, since the 6 is on the other side of the triangle, we know this is the opposite side. And since this is opposite the right angle, we know this is the hypotenuse. So we have opposite and hypotenuse. So go back to your notes. Which trig function used opposite and hypotenuse? If you said sine, you were correct. So the sine of angle x equals opposite over hypotenuse, or in this case, 6 over 10. All right? Now, to find the angle, we have to do something called inverse trig. All right, we have to do something called inverse trig. If you look at your calculator, you'll see the sine button, and the cosine button, and the tangent button. If you look right above those, you'll see these buttons that say sine to the -1, cosine to the -1, and tangent to the -1. A lot of times you have to hit your second key or your shift key, whatever your calculator calls it. You'll have to hit that key and hit the button so you have the inverse sign pop up. All right? Because once you have the inverse sign, then it's real easy to find the measure of your angle. So you would do second sine to bring up inverse sine. All right, now, what you're going to put in here, you're going to put in the ratio of the sides. So we're going to put in the 6 over 10. Okay? So inverse sine of 6 over 10 when you do that in your calculator, that will give you your angle. Okay? In this case, if you do the inverse sine of 6 over 10, you should get, not 3.6, you should get 36.9 degrees. Alright? You should get 36.9 degrees. Okay? This is how you do inverse trig. You figure out which two sides you have. In our case, we had opposite and hypotenuse. And we knew that the sine of x equaled opposite over hypotenuse. So the sine of x was 6 over 10. Alright, so now to find our angle, we're going to hit second sine to bring up our inverse sine. We're going to put in that 6 over 10, so the inverse sine of 6 over 10, and that's how we're going to find our angle measure. Alright, that's how we're going to find our angle measure. So angle x here, we can go ahead and write it in, is 36.9 degrees. Alright, of course now we can find this one, because we know these two angles have to add up to 90, so just subtract that from 90 and you would get that angle. Alright? Now, I want you to try this one. Just write this in your notes. Keep it in your notes. I want you to try this one. I want you to find the measure of angle A and round your answer to the nearest tenth. So go ahead and pause the video, take a few seconds and try to figure this out. Alright, so we're trying to find a measure of angle A. So the first thing we need to do is figure out which two sides we have. Well, the 15 is actually touching the angle A. It's touching the vertex, so we know that this is the adjacent side. And of course, the 20 here is the hypotenuse. So, adjacent and hypotenuse, that's cosine. So cosine of angle A equals adjacent over hypotenuse. Alright? So now we're going to do second cosine on our calculator to bring up the inverse cosine, and we're going to drop the 15 over 20 in there, and then we're going to hit enter. Alright? And you should get 41.4 degrees. So angle A, and that equals the measure of angle A. Okay? So, again, we have our sides. We want to know our angle. We're going to do the cosine of A, because we don't know what A is. We're going to do the cosine of A equals opposite over hypotenuse. I'm sorry, adjacent over hypotenuse. Okay? Remember, that's adjacent over hypotenuse. Alright? So that's 15 over 20. Now, to find the actual angle, we're going to do second cosine to bring up inverse cosine. That's what this is. Inverse cosine of that 15 over 20. Hit enter or equal, and you're going to get the measure of your angle, which in this case comes out to be 41.4 degrees. Alright? Alright, now we're going back to regular trig for one last example. Alright? Say now we have this side. We don't know what this side is. It's x. That's what we're going to be solving for. But we know this angle up here is, say, 5 degrees. How are we going to find out what this side, what the measure of this side is? Alright? Well, here's what you're going to do. First, you got to figure out what two sides these are in relationship to that angle. Alright? We know since this 150 is physically touching this angle, we know this is the adjacent side, and since this side is on the other side of the triangle, it's on the opposite side of the triangle, we know this is the opposite side. So what uses adjacent and opposite? Well, that's tangent. Okay, so we know the tangent of our angle, alright, our angle here in this case is 5 degrees. Okay, so the tangent of 5 degrees equals opposite over adjacent, so x over 150. Alright, now, to solve for x, the first thing we're going to have to do is get rid of our fraction. We can do that by multiplying by the denominator. So we're going to multiply both sides by 150. That cancels that out. So 150 times the tangent of 5 degrees is going to give us x. All right. Now this works for any trig function, sine, cosine, or tangent. All right. What you do is, first thing you do is you figure out which trig function you're going to use by figuring out what sides you have. If we would have had, say, the 150 and the hypotenuse, that's adjacent and hypotenuse, we would have done the cosine of 5 degrees. All right. But since we were given adjacent and opposite, we're going to use tangent of 5 degrees equals opposite over adjacent, and that's how we're going to find x. Multiply both sides by the denominator. So 150 and 150, those cancel out, leaving you 150 times the tangent of 5 degrees equals x. All right. Now you're going to plug this into your calculator. So 150 times the tangent of 5 degrees is 0.087. So 150 times that gives you 13.1. All right, 13.1. All right, so that's how you find a missing side. All right. Now, one more example. I know I said that was the last one, but let's do one more example. All right. So here we have a triangle. All right. Say this was 33 degrees. This was W. No, not W there. Say this was 3, and this was x. All right. So now we want to find x. So what we got to do is we got to figure out which trig function to use. Well, you should automatically recognize by now that that's adjacent, and this is hypotenuse. So adjacent and hypotenuse, that's cosine. So to set this up, we know that the cosine of 33 degrees, because it's the cosine of our angle, equals adjacent over hypotenuse. All right. Now, if you look here, we have our variable in the bottom. All right. So if we multiply both sides by the variable, which is what we need to do, multiply both sides by the denominator, all right, we're going to get x times the cosine of 33 degrees equals 3. Now, we still can't solve this yet because we need x by itself. So now what we want to do is get rid of the cosine of 33 degrees. So we do that by dividing both sides by the cosine of 33 degrees. It cancels out here. And x equals 3 divided by the cosine of 33 degrees. All right? So when your variable's in the bottom, you still multiply both sides by the denominator. All right, the denominator was x. We still multiplied both sides by x. But now there's one extra step because now you have x times the cosine of 33 equals 3. So now you have to divide off the cosine of 33 degrees. All right, to get x equals 3 divided by the cosine of 33. Now, I want to mention this too. This cosine of 33 degrees, you have to keep it together throughout the entire problem. All right. You can't divide this angle and reduce this angle. You can't do that. This has to stay in the form of cosine of 33 degrees for the entire problem. When you get to the end, punch it in your calculator. But don't punch this into your calculator until the very end. Like, don't do it up here. Like, don't do x. Like, don't do the cosine of 33 degrees. Figure out what that is and do x times that equals 3. Because you're going to end up rounding the number, okay? And you don't want to round your number for these. So leave it in the form of cosine of 33 degrees until the very end. Now, since we're at the very end, you can punch it into your calculator. 3 divided by the cosine of 33 degrees. And this will give us 3.6. Okay? So remember, keep this in the form of cosine of 33 degrees until the very end, like I did. Don't change it. All right. So this has been your 8.3 trigonometry video. You can watch this video as many times as you need to. Make sure you're ready when you come to class tomorrow to work some problems. See you tomorrow.